All right, rationalizing the denominator. It's following a set rule. Whatever sign's in the denominator, we're switching it. I'm kind of a big fan about putting parentheses around everything. You probably don't need to put parentheses around the 5, but to be consistent. You're distributing up top. 20 minus 5 root 3. That's going to be your numerator. On the bottom, you're foiling. 4 times 4 is 16. 4 times negative root 3 is negative 4 root 3. Root 3 times 4 is 4 root 3. And root 3 times a negative root 3. When you do a positive times a negative, it's a negative. Root 3 times negative root 3 is minus 3. What's going to happen every single time, if you do the problem correctly, the middle terms cancel out. That's why we do the conjugate. That's what this is called. That's why we do the opposite sign. 16 minus 3 is 13. Now, the better way to write the answer is this. I will accept either way. One subtle change. Seven root 5 plus 63. Root 5 times root 5 is 5. Plus 9 root 5 minus 9 root 5. Negative 9 times 9 is a negative 81. On the bottom, the middle terms cancel out as they should be, getting negative 76. So we get 7 root 5 plus 63 over a negative 76. Now, there are two issues here that you do have to correct. And I don't know if I was clear enough about this when I first introduced it, so let me be real clear right now. One, we don't need negatives in the denominator. Okay? So that negative gets distributed to your numerator. We take the negative out of the denominator, put it in the numerator. And we always put the rational number first. So this is the correct form of this answer. Now, once again, if you want to split it up and make it negative 63 over 76 minus 7 root 5 over 76, feel free. All right, adding and subtracting. You will get one or two like this on the test. The first two are an absolute gift. I misspoke. The second one is an absolute gift. This one's a little bit harder. Sorry. So I'll do this one here first. This one is simply 6 root 3x. If you already have the same thing under the radical, you're good. Here, we've got to get the same thing under the radical before I can add or subtract. So 12, 2 and 6, 2 and 3. 27, 3 and 9, 3 and 3. So this becomes 4, 2 root 3, plus 7, 3 root 3. 8 root 3 plus 21 root 3 is equal to 29 root 3. Here, 18x cubed y. The 18 breaks down to 2 and 9, 3 and 3. So it's 12 times 3 on the outside, 2 on the inside. 3 divided by 2 is 1 remainder 1. X, X. The y to the 1 is less than the index, so we just leave it. Oops. There we go. I'm going to actually move this root 2x a little closer. Root 2xy. A little bit closer. There we go. Okay. Now for the 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Pair of 2s, pair of 2s. Minus 2 times 4 root 2. 3 divided by 2, x, x. And then we have a y. So we end up with 36x, 2xy, minus 8x, 2xy. And look for it on the test. You're going to get numbers outside the radical you can combine. And what's in the radical you can leave. And that's your answer. I'm going to put the 16, 2 and 8, 2 and 4, 2 and 2. This translates to 4 times 2 cube root 2. 54, 2 and 27, 3 and 9, 3 and 3. 3 cube root 2. Eight cube root 2 plus 15 cube root 2, 23 cube root 2. And that's our answer. All right, so when you get something like this, just simplifying this radical. The number we simplify as we've done in the past. 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. There's 5 2's. So 2, fifth root, 2. The quotient is the exponent on the outside, the remainder on the inside. 9 divided by 5. 1, remainder 4. 11 divided by 5. 2, remainder 1. 15 divided by 5. 3, remainder 0. So if the 0 is a remainder, you don't put that variable back in the radical. And that is your answer. You're simplifying the radical, the number of it, and you're simply just dividing quotients, the exponent on the outside, remainders, the exponent on the inside. 54, 2 and 27, 3 and 9, 3 and 3. 3 goes on the outside, cube root of 2. 14 divided by 3, that is 4, remainder 2. 16 divided by 3, that is 5, remainder 1. And z to the 2, anytime the exponent is less than the index, we just leave it. And there's your answer. Once again, so when you do this, once again, this is about making good decisions. A little easier when there's not a fraction in front. I'm going to start with 3, 2. Then I'm going to put 4 in for x. 4 minus 3 is 1. The square root of 1 is 1. 1 times negative 2 is negative 2, and negative 2 plus 2 is 0. So when x is 4, the y is 0. Now, I want to get another perfect square. So I'm going to go with 7. So when I put 7 in for x, 7 minus 3 is 4. The square root of 4 is 2. 2 times negative 2 is negative 4. Negative 4 plus 2 is negative 2. Finally, if I want to get to a 9 there, I'm going to put 12. 12 minus 3 is 9. The square root of 9 is 3. Negative 2 times 3 is negative 6. Plus 2 is a negative 4. And these are the points I'm plotting. Now, for the sake of the video, I understand that on the packet you got, the 2 was a positive, so I will draw that graph as well. Okay, we have 4, 0, we have 7, -2, and 12, -3 is somewhere out here. Okay. If you want the answer from the packet, unfortunately I wrote a positive 2 there, but I did want you to negative. It would look something like this, just so you have the correct answer, though. It would look like this. The red line being what's in the packet, the black line being what's on the board right now. For everyone's packet, do you have a positive 1/2? Okay, good. All right. So here, I would deal with the fraction a little bit. -1, -4 is my starting point. -1, -4. If I plug a 0 in, the square root of 1 is 1. 1 times 1/2 is 1/2. 1/2 minus 4 is -7/2, or -3.5. That's not a brutal fraction. Okay. So here I'm going to use 3. 3 plus 1 is 4. The square root of 4 is 2. 2 times 1/2 is 1. 1 minus 4 is -3. If I want to do one more, I'll do 8. 8 plus 1 is 9. The square root of 9 is 3. 3 times 1/2 is 3/2. Minus 4 is -5/2. So 3, -3. 8, -5/2. And this is what the graph should look like. Okay. So we have our 4xy. I've got to simplify in the radical. So I'll put it down here. 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. We have 4 2's. And the 4th root of 2. 7 divided by 4. 1, remainder 3. 13 divided by 4. 3, remainder 1. Now I'm going to simplify the 162. 2 and 81. 3 and 27. 3 and 9. 3 and 3. 3, 4th root 2. 11 divided by 4. 2, remainder 3. 17 divided by 4. Y, or 4, remainder 1. Okay. Now, okay. When I multiply here, we get 8x squared y to the 4th, 4th root of 2x cubed y. 9x squared y to the 4th, 4, 2x cubed y. So it does end up working out, alas, okay. And then we add 17x squared y to the 4th, 4th root, 2x cubed y. You will get one question like this on your test as well.